Hey Garrett,
Hey, Miss Sparks.
how are you?
I'm good.
Good.
I wanted
I think I
what?
think we're on a different section than you guys are. So you might want to remind me where you guys are so that I can help you.
I'm on page 114,
Okay. Let
and
me,
it's
let me
3 through 39 odd.
okay. I'll probably end up having to refresh this actually because I've been sitting here. 114, right?
Yeah,
What section is that? Do you know? Is that 2.4?
yeah. I've only watched the first video in Ed Puzzle, so I'm not like completely understanding of this concept, but I wanted to still do Math Lab.
Oh, okay. I got you. Well, we can certainly do that. And I think that you said it was three through what odd?
39.
39. Okay. Okay. On the first few, on three, basically it's gonna I'm pretty sure she did the same videos as I, but basically to kind of get you up to speed, the video should be divided out like how you're going to kind of address each section. So like example one on these where it says factor the polynomial completely, on the monomial factors, you're going to look for a common uh like a greatest common factor, and then you'll factor that out first. So for sorry about that.
Wouldn't it be 7?
Yes, perfect. But I think the variable might be able to factor out too. I don't have it in front of me now because I
Wouldn't
moved to this. So
7x?
let me move back there. I'm sure that sounds good. Yes, 7x, perfect. So and then so you would write that out, and then you would then in so you would write the 7x, and then you would do an open parentheses and then write whatever you had left.
Your audio cut out.
The audio cut out.
Yeah, I didn't hear anything you said.
Okay. I feel like when I'm switching back and forth, can you hear me right now?
Yeah.
Okay. I feel like sometimes when I switch back and forth, when I toggle in between screens, I think my video cuts out for some reason. And that's weird to me. But that's kind of what's been happening.
So how exactly would I write this?
Um, Let me make sure that I write it here so you could see a good example. So you would write it like this. And then that's factored completely.
Where did the 2x minus 3 come from?
If I take a 7x out of 14x squared, like if you're looking at
Oh,
14x,
you divide it by 7x.
yeah, and you're pulling that out, like you've got 7 times 2 times x. And you told me that the 7x,
No, like you got 14x divided by 7x, which literally, or 14x squared divided by 7x, which gives you 2x. And then 21
exactly.
got rid of the x because there's only one in both. And
Hmm.
then 21 divided by 7 is 3. But since it's a
Yes.
negative 21, it's a minus 3.
Yes.
Okay,
That's
I get it.
exactly where I got it.
Could you give me
That's
just a
it.
second?
Oh, yes, I can.
Okay, I'm back.
Okay. I was just going to go ahead and write down number 5 while you were away.
My phone rang, or the landline rang. Didn't know
Yes.
who it was.
Um, so on number 5, what would you say the greatest common factor is?
C.
Yes. And then you just write what's left over after you take the C out of each individual term.
So it's C. I'm not looking at the screen right now, but it's C squared plus 9C plus 18.
Yes. 9. Did you? Yes. You said 9C for the middle term?
It's basically everything, but just with one less C.
Yes, sir.
Is that the final answer?
No, you're not that lucky, Garrett.
Or do I have to keep distributing out in this other parentheses, like the 9 and 18?
Well, on this particular one now, this you should recognize this as a quadratic form, and you would factor it like we did our quadratics in the last section. So you're going to look for two things that multiply together to give you 18. When combined, will give you a 9. So what are the factors of 18?
2, 3.
Yes. 2 and 9, 3 and
6.
and 3 and 6 add up to be 9.
Okay, so how do I write that?
C plus 6, C plus 3. Remember these good old factoring problems?
Wait.
And now that has been factored completely. So it would be a C times C plus 6 times C plus 3.
I kind of understand that, but I'm still a little fuzzy on it.
Okay. Well, you got I know you got the greatest common factor. You rocked on that. You were good with that. But this factoring right here is just a review of kind of what we had in chapter 1 when we were factoring quadratics. I think I eerily said in a lot of the math labs, this is never going away. It's going to continue to follow you in chapter 2 and chapter 3 and continue to follow you right on into pre-calc next year. Factoring's never going away. But so basically, in last chapter, we factored just quadratics to find out, basically the whole point was to find out where they would cross the x-axis kind of thing. We were finding solutions. But factoring a quadratic is where you take the constant term on the end and you find the factors of it. Because if I were now to take C plus 6, basically factoring is dividing. If I were to take C plus 6 times C plus 3 and multiply them like you did in 2.3, remember we went back to multiplying polynomials?
Mm-hmm.
And you foiled, and you would get this. And then you would combine like terms, and you would get this.
I mean, I know that. I was just kind of wrap my head around it.
Okay.
I know that it works when it makes sense when it's written down, but I don't know how to produce it.
Oh, I got you. Great way to put your question. So what you want to do is I think there was somebody that actually does it like this. They do the multiplication on one side and the addition, subtraction of the factors on the other. So what you're doing is you write 18 at the top and you write the factors of 18. 2 and 9, 3 and 6, 18 and 1. So if I were to add 2 and 9, I would get 11. If I were to add 3 and 6, I'm going to get 9. If I were to add 18 and 1, I'm going to get 19. Well, the only one of these that work is this line right here. Does that help?
Yeah.
So this is the left side is where you're multiplying and coming up with the factors, and the right side is where you're adding or subtracting, because sometimes we subtract. You know, you find the difference of them when this is a negative. Did that help?
Yeah, a little bit.
Okay. And so then once you finalize what the factors are, you put them back into your little tiny binomials here. So C plus 6 and C plus 3. And 7. Hey, something I wanted to point out that I didn't know before. Do you see in your textbook where the number 7 is circled with a red circle?
Yeah, they're written out problems, right?
Yeah, in the back. You already knew that?
Yeah.
You're a genius, Garrett. I just learned that. That's really awesome. Okay.
Is the first step for 7, goodness sakes, 3y parentheses, y to the 4th minus 16y to the 2nd?
Well, you can get a little bit more y out.
Can I do
So
I could do y to the 3rd, right?
yes, good job.
Which make that y to the 2nd, and we make the y go completely away on the other one.
On the second term.
So it'd be 3y cubed parentheses y squared minus 16.
Is that this is what I got? Is this what you got?
That's what I got.
Huh?
Yeah.
All right.
Yes.
Now, once again, referring back to chapter 1, this second thing there, the y squared minus 16, that's the difference of two squares. Do you remember learning about that?
Refresh me.
This y squared is a perfect square, and this negative 16 or this 16 is a perfect square. So you can actually write this when it's the difference of two squares. That means there's a square in the front and a square in the back with a minus sign in the middle.
Yeah, that makes sense.
And so then, and basically it factors down to y plus 4, y minus 4, because the whole point is that middle term cancels itself out. So if I were to actually FOIL this completely out, that middle term that we often get cancels out. And so you're just left with the leading term and the ending term.
Okay. This
All
next
right.
one's matching, right?
I'm sorry?
Next one's matching.
Yes. Not too bad. All right. At least you have some multiple guesses, right?
Mm-hmm.
There's a chance to get it right.
25% chance to win.
Yes, that's right. And that's better than 0 or, minimal, right? So what do you think the greatest common factor is?
2. 2x cubed.
Yes. So when you look down there, are all of them 2x cubed? Yes. So, you can't even do any processes of elimination with regard to that, can you?
No.
That's kind of a bummer. I always like it when you have a multiple guess and there's like, oh, I get to eliminate 2 choices just purely based on the first thing that I know. So we know we're going to take a 2x cubed out, and then that's going to leave us with what? X to the 4th? Yes? Minus, what, 16?
Mm-hmm.
Okay, now, would you agree with me that this x to the fourth is really a perfect square of x squared squared?
Yeah. Mm-hmm.
Okay. So we're going to do this.
This is going to be 2x to the third, x squared, plus 4, parentheses x squared plus 4.
Like -4 plus 4, because once again, this is the difference of two squares. So I've got these two factors that pull out. Okay?
That doesn't show up in the matching, though.
Yes, I know. It's because we're not done having all kinds of fun with this.
Wait
You
a
just
minute.
because which one of these is also the difference of two squares? Which one? Which one of these two factors, which is two squares with a minus sign in the middle? Hint, hint.
I don't know.
X squared and 4. Both of those are perfect squares.
Oh, you're right. You're right. I forgot.
Yeah, I know. When they get little like that, you know what's really weird? You know, the hardest one to recognize is when it's x squared minus 1. Because we always forget that 1 is a square root of itself. So this is actually going to then turn into this.
Wait, we were just factoring out that 1, right?
I'm sorry?
How come we didn't do the same thing to the other one?
Because it's not the difference of two squares. It's the addition or the sum of two squares, which literally it doesn't factor down anymore. I mean, it does factor down, but not where you are yet. Those are imaginary zeros. So you don't learn that till pre-calc. This is as far as you go in Algebra 2. So this is its fully factored form. So you just have to I will tell you that special pattern factoring appears quite frequently in Algebra 2 and pre-calc. So being able to recognize these differences of squares is very crucial. Does this make sense to you? I'm sure that it makes sense, but being able to look at it and work it out sometimes is a little quirkier. So the answer would be A for that one. Are you there?
Yeah, just give me a second. I need to get a new pencil.
Oh, okay. You already wore that one out with all that we've done.
Okay, got a new pencil.
Okay. I didn't want to erase this one before I knew for sure that you had it down. Did you get it down?
Oh, yeah.
Okay. Okay, the next section is once again where we're addressing some special factor patterns, like we're factoring with special patterns. And remember how I told you just a minute ago, when it's the sum of two squares, you can't factor it any further, only when it's the difference of two squares. Remember? But that is not the case with cubes. You can have the sum or difference of cubes. Not squares, but cubes, you can have the sum or the difference. And that's mostly, there's lots of other reasons, but one thing that we can remember, you know how I said the tricky one is when it's x squared minus 1? It's hard to remember that 1 is like a, is a square of itself, when you think of, you can't take the square root of a negative, right? You can't take the square root of a negative, and we already learned that that's the letter I. But you can take the cube root of a negative, right? Because that's going to be -1. Because -1 times -1 times -1 is -1.
Oh, that makes sense.
And so that's why you can do the sum or the difference of cubes and factor them with special factoring patterns. Okay?
Okay.
And so only with the difference of squares do you have special factor patterns. But with the sum and the difference of cubes, you have special factoring patterns. And that special factoring, which this will all kind of make sense once we do a little more of it. I'm just going to write them down. These are in your textbook.
Are we doing number 11 or?
Yeah, I'm working on number 11 now, but I'm trying to kind of set up for it so that when hopefully it will help you recognize the pattern. So number 11 is y cubed minus 64. And it says factor the polynomial completely, but it's under the directions of sum or difference of cubes. So I pretty much know right off the bat that this is going to follow one of these. So does y cubed minus 64, what is that going to be, a sum or a difference of cubes? Just you're focusing on that middle operation.
Difference.
That's a minus sign, so it's going to be a difference. So what I want to explain is that I use the acronym SOAP to help me remember which one of these two things I use. And what that means is it's same, opposite, always positive for my signs. So I know that I'm going to use this factoring pattern for it because I'm going to apply the same factoring pattern. So it's going to be y minus, what is the cube root of 64? Do you happen to know? If you don't, I can tell you because you're.
How do you do that on a calculator?
Sure. Yeah, I think so. I don't know how to do it on the calculator.
I mean, I can do a square root, but I don't know how to do a cube
Yeah,
root.
there is a way, but I'm not absolutely sure. I think it's the symbol with the X in the check mark. Like I think on the calculator, it looks like this. Is there a button like that?
I don't see anything like that. I see the normal one.
Okay.
It's weird. So how would I find that without a calculator?
I That I don't really know. I'm almost sure that there's a button. I don't have my calculator in front of me. I have most of my cubes memorized pretty high, and it's almost something that I feel like you need to do going forward. Like 2 cubed is 8. 3 cubed is 27. 4 cubed is 64. 5 cubed is 125.
So
It's
it's
just kind
4.
of a good idea to memorize them, honestly. But I'll look. I'll pull my calculator in just a minute and try and figure out what the button is. My calculator's been dead for over a month. I really, really need to figure out what's going on with it. I guess I need new batteries. I just thought when you could recharge them, the batteries never went dead. But apparently that's not true. All right. So for your cubes, for number 11, knowing the cube root of 64, but basic is 4. So what you're going to do is to factor it, you're going to factor it knowing you're going to use this pattern, this A minus B, because you're going to pick the same operation goes in the first one with the cube root of each of them. The cube root of y cubed is y, and the cube root of 64 is 4. And in the second one, you've got y squared, and then you work on opposite. It's going to be the opposite sign of the first one. And then the last two are, the last sign is always positive. So it's the same in the first, opposite is the first sign in the second term, and always positive is the third sign in the last. So I use the acronym SOAP. Same, opposite, always positive, to memorize my difference of cubes. And then you know it's the cube root. And the second part is always the cube root of each of these multiplied together. So the cube root of 64 is 4, and the cube root of y cubed is y. So this middle term is just the two of them multiplied together. And then the final term is the 4 squared. So it's squared terms on that second factor, and you're done at that point. So this is a little bit of memorization.
Wait, that's the answer?
Yep, you're done.
I don't have to do anything else? Okay, good.
No, you just have to follow that pattern. And I was just trying to give you tips on how to memorize the pattern.
I thought you were setting up to like start doing more to it. I was like, oh no.
No, that's it. You're done. I was just trying to give you helpful tips on how to memorize the pattern of the cubes, because it's easy when you can look at it and it's in front of you, but trying to then go, okay, what do I do with cubes on a test? So if you can remember SOAP, it kind of helps you remember, because it's not too hard to remember, you know, that you're going to put, you know, just the single terms in the first place, and then the cubes, there's the squares in the second one, and all of that. But trying to keep your signs straight, and that can be a daunting task unless you have like a little, you know, little help from a friend, an acronym friend. All right, number 13.
I'm trying to figure out how to take the cube root of the calculator.
Oh, you're okay. I know there's a button.
Oh, okay. I think I figured it out.
Okay.
So you press the math key, and then there's the cube root of, what's the cube root of 64? It's 4, right?
Yes.
Okay, I figured out how to do it.
Okay. All right. So since you know we're working with cube roots, then you know that 125n cubed, we know that's a perfect cube. So what is the cube root of 125n cubed?
Hold on, I made a mistake. 5.
Yes. So 5n, because you can't forget that n.
I was just talking about the first part of it.
Oh, okay.
And then the other one is 6.
Yes. So then we've got the same sign in our first one. So 5n plus 6. And then we know that it's going to be opposite. And this one is going to be the square of this first term. So what's the square of 5n?
25 n, or yeah.
Squared. 25n squared. And then using our acronym, we've got same and then opposite. So the sign is going to be minus. And then the second term is A times B. So that's 5n times 6.
30n.
Yes. And then the final one, the sign that goes in the middle, that's always positive. So plus, and you put in 6 squared.
36.
Mm-hmm. So that was the sum of two cubes, and that's its final factored form.
I think it's trying to kind of grasp it a bit more.
I'm sorry?
I said I think I'm starting to grasp it a bit more.
Oh, yay. Good. Love that. Can I erase that one?
Yeah.
Okay, so number 15. Is 8c cubed plus 343.
The first parentheses, I got 2c plus 7.
You go. That's awesome.
Then 4c squared, right?
Yes.
And then
What's my sign?
it would be minus.
Good job.
And then I'm trying to remember how I did that. No.
You were on target, I think.
14c
Yes.
plus 49.
Yes. Good job.
Okay, 17. What do I do if it doesn't come out perfect?
See if you can factor something out first.
So would it be, hold on, I got to rewrite this because I don't have space in my paper to write this.
Okay. Oh, I'm sorry. I was throwing my stylus around the room.
Sorry that I'm taking a while. I gotta fix something.
Oh, that's all right.
The blinds were letting all this light in. It was like directly on my face.
Mm. I guess that means the sun's coming out.
Mm-hmm.
Praise the Lord.
Okay, I'm good now. So would it be, well, one of them's negative, one of them's positive.
Yeah. So I would personally pull the -5 out. And then once you divide 320 into -5, then you're going to get a -64. And they weren't going to let you, basically what they're trying to do is kind of make sure that you recognize, even though the heading of the section says sum or difference of cubes, we can't forget that sometimes we can look for a greatest common factor.
So that's the final answer, or do I...
No, you're not that lucky, Garrett.
Trying to figure out how I could do this further.
The z cubed is a perfect cube and 64 is a perfect cube. So it's the difference of two cubes.
Is it Z and 4?
Yes.
How'd you get that?
How did I get what?
What you just did.
It's the difference of two cubes, and I just used the factoring pattern.
Like
the soap, same, opposite,
okay.
always positive. And then I used the factoring patterns that we've been using. But I had to leave my -5 there because that's still one of the factors.
These next ones look kind of hard.
Oh, the factor by grouping? It's not too bad. Did you understand where I got number 17 okay at the end? Because I know you said you didn't see where I got it, but did you get it?
Yeah.
Oh, okay. All right. I just wanted to make sure before we moved on if I needed to rewrite it and explain it, because I knew I was going to go ahead and finish working it, because I feel like you're doing your work there and then looking up to see if you're getting the right answer. So I just wanted to, that's why I continued working. Are you okay if I get rid of this, all this sum and difference of cubes and the patterns and soap and all that?
Yeah.
Did you get that written down?
Patterns?
Yeah, the patterns.
No, I did not.
Did you want them written down? I mean, they're in your book.
Where in the book?
I think it's on the page, two pages before we are, but I can write them again.
Oh, I found it. I'm good.
Okay. The only thing you might want to do is write in your book or write in your notes that soap thing, because believe it or not, you'll get the rest of it memorized, but those signs can be the tricky part. So it's a great acronym. I actually just learned the acronym, I think last year. And I was like, where has that been my whole life? Because I just tried to memorize the patterns themselves without, that was such a huge light bulb moment. I'm like, oh, that's so awesome. It makes memorizing it so much easier, you know?
Mm-hmm.
I'm sorry, I can't read the book. The print's so small, so I was struggling. The struggle's real, Garrett, when you're old. 7y squared plus 4y minus 28. Okay. We're going to factor by grouping. So what you're going to do, and you can only do this when there's 4 or more, but there's for algebra 2, it's always just going to be 4 terms. So it's always a good way to check and see if there's 4 terms. And then what you're going to do is turn it into just 2 smaller problems and pull out the GCF. That's what you're going to do first. That's the first step. All right. So you group 2. And so now in that first grouping that I have on the screen, the y cubed minus 7y squared, what does this have in common?
Y squared.
Correct. So I'm going to pull that out. And then what do I have left?
Y minus 7.
Correct. Okay. On this second one, what can I pull out?
4.
Okay. And then what would I have left?
Y minus 7.
Yeah. Okay. Now, there is a common factor in each of these, isn't there?
Oh, I remember this. Would it be,
Okay.
is it y minus 7, y squared minus 7?
It's y squared plus 4 times
okay.
y minus 7.
I was doing the back part of the problem first.
Oh, okay. That's fine. The y minus 7, you put it first. That's fine. It doesn't, obviously, it's multiplication. So in the end, it doesn't really make much difference which one you write first.
These make a lot more sense because you just kind of, it's not very complicated compared to the other ones.
Yes. The other one, I feel like in all honesty, you've got to do a few of those to really get the hang of those, because you're working with kind of a special factoring pattern. And I think when you're working, in my opinion, when you're working with patterns, it's one of those things that you have to do a few of them to really start to recognize the pattern and feel comfortable with it.
Would it be 3m minus 1 or just 3m?
3m minus 1. I'm so glad that you said that. That's very, very important because for whatever reason, the factor of 1, a lot of students just forget to leave it out. So that was awesome. So proud of you. That's amazing.
Wait, how does the second one work though? Wouldn't the 3 be negative?
I would just pull out a positive just because the 9m is positive. So I would pull out a positive 1. And then that way I'm going to end up, if I take a 3 and divide it by 3, I'm going to end up with my negative
Okay, I
1,
get
which was
you.
kind of my goal in the first place. You know what I mean?
Mm-hmm. Where people keep calling.
Y'all are popular.
For spam.
Yeah, true.
$23.
I'm going to give you a heads up on 23. One of your factors at the end is going to bring back one of the factoring patterns that we've talked about today. Okay? So you're going to have to recognize, okay, is that a perfect, one of the many? I think it's going to be the difference of 2 squares, but I kind of want to give you a heads up about that. You knew they were going to throw in a twist, right?
Mm-hmm. Oh, man. Would the first one be? Oh, you're doing it.
Yeah. Did you get it?
Mm-hmm.
Yay. Now, this one I am taking a negative out because the goal is to try and get, a matching term on the right hand side. So I
Mm-hmm.
did pull a negative since both it was minus 9C, minus 18. I went ahead because there was a negative term in both of them. I went ahead and pulled a negative out. Plus, the whole goal was for me to hopefully match the second terms. Does that make sense?
Yeah.
Now, do you recognize this first term to be anything special?
Perfect squares.
Yes, the difference of perfect squares. Good job. Amen. All right, so what's the square root of 4c squared?
2c minus 3.
Yes. And since it's the difference of two squares, the first factor is going to be 2c minus 3, and the second factor is going to be 2c plus 3.
That's the answer.
Yes, that's the final answer. Okay, for number 25, the instructions say quadratic form, and then it says factor the polynomial completely. So what it's trying to do is tip you off about the fact that this is, even though the highest degree of the polynomial is a 4, it's still in quadratic form all the way across. And what I mean by that is the first term is actually a perfect square. And the second term, it goes down by 2. So it's kind of cut in half. So if you have a trinomial where the beginning term is 4 and the second term is 2, it's still in quadratic because basically this is a squared square, and then this is just a squared. Okay? So what you're going to want to do then is our little table that we did before, where this is multiplied and this is added. And the factors of 6 are 6 and 1, 3 and 2. And when I add 6 and 1 together, I get 7. And when I add 3 and 2 together, I get 5. So these are the factors that I'm going to want to use in my quadratic, but it's going to look a little different than it did before. As before, we would just write a plus 6. This time we're going to write a squared plus 6 and a squared plus 1. But it's still in that quadratic form.
Okay. Is that the final answer?
That's the final answer. We don't have to do anything else to that one. Yay.
Okay, 27, 32.
27 definitely has some special things to it. Can you see anything that we can factor out of both terms as far as a greatest common factor is concerned?
Two, I guess.
And a z. Does that make sense?
Mm-hmm.
And then this is the difference of two squares. The 16z to the fourth minus 1, because 16 is a perfect square, z to the fourth is a perfect square, and 1 is a perfect square. Oops, I think I'm going to change that. So that's the sum or the difference of two squares right there. And we have it again. When you look at 4z squared minus 1, that also is the difference of two squares. That's why these factoring patterns are really crucial to be able to recognize.
I think it's going to take a little bit more practice for me to understand this stuff.
Yeah, I feel like the key on all of this is recognizing the patterns.
I'm surprised no one's come to math lab yet.
Yeah, I know. I'm kind of surprised too. They might at this point think that it's over, you know, because it's been an hour since I posted it. But I don't know. I'm kind of surprised too. But do you, after I tell you that it's a special factor pattern, do you see it?
Yeah, I do.
But what you're thinking is maybe you wouldn't see it had I not pointed it out. Is that correct?
Yeah.
Okay. That's what, yeah, I think I actually, I started teaching Algebra 1 after you had already had it, I think, because I'm teaching it now. And I actually make all of my students that second semester do an entire page of special factor patterns. Just because it is so, I mean, you're even going to see it in trig, like in trig, you'll see it even in trig identities. So it's like really important to be able to recognize it with what I consider more user friendly, that when they start adding sine and cosine to it, it's even scarier. But okay, what was that? 27?
Mm-hmm.
29 isn't quite as ugly, believe it or not. 27 of all of those, I think, was actually the worst of all of those. Like, not the worst as far as it definitely had the most patterns. So you know what you might want to do, Garrett, is actually circle that in your book And just a couple days from now, go back and do just that one, just to see if you can recognize the patterns, before a quiz or something.
Mm-hmm.
Like make a note to yourself. 27 is a good one to work before a quiz. Okay, number 29 is 15x to the fifth minus 72x cubed minus 108x. So we want to see if we can factor something out. And I know 15 won't factor all of them. And I know 5 won't factor all of them. But I believe 3 will. And do you know the divisibility test for 3?
Yeah.
Okay. So I can take a 3 out, and it looks like I can take an x out of each one. Oops. So now I'm going to set my table up over here, my multiplication side and my addition side / subtraction. So what 2 factors? Oh, we got to slide and divide. Do you remember sliding and dividing?
Yeah.
I probably didn't leave myself enough room on this one. Okay. Through a lot of trial and error, I think I have so if I do 18 minus 10, I have 2, and 20 minus 9, I have 11, and 30 minus 6, I have 24. So it's going to be x squared minus 30 x squared minus 6, and then you're going to divide both by 5 because we slid. Now we have to divide. So this gives me x squared minus 6, and this gives me 5x squared minus 6. Or plus 6, actually. This would have been a plus because my higher one needed to be. the positive, the negative one, and my lower one needed to be the positive. So that's actually your final answer.
Okay. Are they gonna be like this on our tests and quizzes?
I don't know that one in the quadratic form will be as hard as that one. I can't even remember. It's been a while since I've looked at the quiz on that one, but I'll check it out. I think it will be a little more like number 20, like what we didn't do 24, but one like 24 or one like 25.
Okay.
But I would definitely write down number. It might be like 27 in that it might, once you get it factored, there might be another sum or difference of squares in it, but it won't be one. It'll be more of a recognizable one, like x squared minus 9. Does that make sense?
Mm-hmm.
What number was that? 29?
Yeah.
Okay, 31 is to find the error. See if you can find the error on 31.
I can barely figure out how to do it normally. I have no idea.
Okay, well they factored right at the beginning. But they left the one factor out, the 3x factor.
Mm-hmm.
They left that one factor out, and believe it or not, that's an important factor. That 3x, like they factored pretty well. I would, and to me, it looks like they skipped some steps, which that always causes an error. So then they would have had this, because this is the difference of two squares. And to find the real zeros, remember how we would take each one of these little factors and set each one equal to 0? To find the zeros.
Mm-hmm.
They left this one out, and that's important. I know it just turns out to be 0, but the whole point is to find out where this thing crosses the y-axis or the x-axis. I'm sorry. So they left that one out, and it basically means it's going to cross it, at 4, at -4, and at 0. So all of that is important. So they left one out. When they were factoring completely, they forgot to bring down that 3x, and you can't forget to do that. Okay?
Mm-hmm.
Do you see that now?
Yeah.
Or not really?
Vaguely.
Okay. All right, look at theirs and then look at mine. They skipped a step though. See, they have right there on their step where they have x squared minus 16. See where they went from they have this step right here that I have. Okay? And then they went to this. What did they leave out?
3x.
Yeah, and that's what I'm saying. That's really important. You have to bring that down. And then they didn't really show the factors of this. They didn't show this being factored. Those are each of the factors. And then you can find the real zeros, because you take each factor and set it equal to 0 to find the real zeros. See how I took each factor?
Mm-hmm.
And then you solve for 0. And they only have these two. They don't have this one.
Should I write this down?
I mean, I would if I were you. It's pretty important moving forward. 31 is a little more like number 33, 35, and 37. And I have an appointment at 1 o'clock, so I'm only going to be able to go over a couple more of those with you. So you might have to ask Miss Wynn about those in class tomorrow. Are y'all going over this in class?
I assume so.
Okay.
I actually have to leave right now, actually.
Oh, you do?
Yeah.
Okay. Well, number 31, you will apply that same principle for finding the real zeros, or you can ask her to go over them in class tomorrow to do number 33 through, and all the odd there.
Okay.
Okay.
Thank you.
No problem.
Bye.
All right. Take care. Bye-bye. Shh.